One form of deductive reasoning is known as the law of detachment. In symbols, the law of detachment is if P implies Q and P, then Q. Let's go ahead and write that in words. So what this is saying is that if P implies Q and we have that P is true, then Q is also true. Let's go ahead and look at the truth table to this law. To make it easier, I have the truth table printed out, so we're just going to fill it in. So let's go ahead and list our different options for P and Q. We can have both of them true. P can be true, Q can be false, P can be false, Q can be true, or they both can be false. Now remember, for P implies Q, that is always true unless we have a true hypothesis leading to a false conclusion. So this is the only place where P implies Q is false. So now we're looking for P implies Q and P. So P implies Q is true and P is true, so this is true. P implies Q is false and P is true, but not both of them are true, therefore the second one is false. P implies Q is true, but P is false, so this is false as well. P implies Q is true, but P is false. We need both of them to be true for a conjunction, but since P is false, this is false as well. So now we're looking at P implies Q and P, which is this column here, and we're looking to see if that implies Q, if that's true. So true implying true is true, false implying false is true, false implying true is true, because you can have a false hypothesis that leads to a true conclusion, and false implying false is true. So you can see that the law of detachment is always true. And that's just one form of deductive reasoning. Another form of deductive reasoning is known as the law of syllogism. In symbols, the law of syllogism is represented by what this is saying is that if P implies Q and Q implies R, then P implies R. So let's go ahead and write that in words. So if this says, if P implies Q and Q implies R, if those are both true, then P implies R is also true, or is true as well. So let's go ahead and look at the truth table to this law. So this is the truth table that I have set up for the law of syllogism. Now we have 3 different statements as opposed to 2. We have P, Q, and R. So I'm going to go ahead and list the options for that. All 3 can be true. So those are the different combinations. There's going to be 8 different combinations for 3 statements. Now, P implies Q. We have true. P implies Q, true. This is a true conclusion leading to a false hypothesis. So this is false. A true conclusion leading to a false hypothesis is also false. And the rest are true, because false hypothesis can lead to both true conclusions and false conclusions. So now we're going to look at Q implies R. True implies true. True cannot imply false. False implies true. False implies false. True. True cannot imply false. False implies true. And false implies false. And then we're going to look at P implies R. So that's true, false, true, false, true, 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 and true. So notice each of them have 2 areas where they're false. Now we're going to look at P implies Q and Q implies R. So we need both of them to be true since it's a conjunction. So P implies Q and Q implies R. Both are true here. One is false. One is false. P implies Q is false. Both are true. One is false. Both are true. And both are true. So now we're going to look at P implies Q and Q implies R. So this column here. And we're going to see what we get if that implies our P implies R column. That one there. So true implies true is true. False can imply false. False implies true. False implies false. True implies true. False implies true. True implies true. And truth implies truth. So you can see that for the law of syllogism, which is this last column, everything is true. Law of detachment and law of syllogism were just 2 different forms of deductive reasoning. And you can see they can be shown as true with a truth table.